Hi everybody and welcome. Today we're going to be talking about the graphs of quadratic functions. So to start off, another example of quadratic motion. I don't know if anyone's ever done this before. It's basically you just have like pressurized air and a bottle of water. And then when you release it, it turns into, basically it shoots itself up into the air. And if you ever watch the flight of those, it usually will go off kind of like straight up and then drift its way over and then come back down. And that's another example of that parabolic shape of kind of like that upside down U, again, where you like go up and then you gradually come back down. And that's kind of the idea here again, with this as another concrete example of quadratic motion in the real world. So with that being said, we're going to jump into our definition today. We're looking at graphing these by hand. So starting off, important features of graphs are their intercepts. The intercept of a graph is where an equation crosses an axis. So if we're looking at a coordinate plane with our y-axis and our x-axis, and let's say we have a parabola going through it, maybe like our little rocket that we were talking about there. We start off here, it goes up, it crosses the x-axis, so we call that an x-intercept. It then crosses the y-axis, we call that a y-intercept, and then it comes back down and hits the ground. So that is our next x-intercept. So again, 3 intercepts there, 2 x-intercepts and 1 y-intercept. And again, with our motion, we're just looking for anywhere that this parabola touches either the x or y-axis, and that tells us that it's an intercept. And as you can imagine, pretty key features for making a graph. For example, if you're only given the intercepts, so someone tells you, okay, it's here, there's another one here, there's another one here, well, based off of that, you can have a pretty good idea of what your graph is going to look like, especially if you're drawing it by hand. So that's why these are important, is we're going to use them to make our graph. So let's go through an example of a quadratic in standard form. We're going to be taking some skills that we already know how to do and then going step by step with them. So let me drag this down here so we can see it better. So first things first, the y-intercept is where we cross straight up and down the y-axis. So this is where x equals 0. Well, in this case, so that's always true for y-intercepts. They're always 0, comma, something. So that's our job to find that. So we can actually just plug that in. So y equals 0 squared minus 0, again, substituting for our x's here, minus 6, or y just equals minus 6. So that is our y-intercept. And you can see that here is that it's just negative 6. It's almost always the number that's by itself without any other variables. We just have to make sure that those x's do cancel out when they equal 0. So it's always good practice to plug in a 0. That way you won't ever be tricked. Next, the x-intercept. So these are a little bit more involved. We know that we find these by doing the box method. So first, last, list out our factors here. Let's try 3 and 2. They have a difference of 1, which is what we're looking for. We want to make sure that the 3 is negative and the 2 is positive, because I'll get the negative one that we're looking for. Okay, so we're left with x minus 3, x plus 2 equals 0. So we'll split these off like we've been practicing. Add 3 to both sides, and we'll get x equals positive 3. And then on this side, we'll get x equals negative 2. So those are the x-intercepts, or to be more specific, our coordinates are 3, 0, and negative 2. Again, that's our x value. Y is 0 here. Our x value, y is 0 here for the x-intercepts. Next step, vertex. So moving our way down here. Well, we know our vertex formula, the x of the vertex equals negative b over 2a. So let's go back to our equation up top here. And if we're looking at this again, a squared bx and c, well, there's our a, there's our b, and then our c is right there. So to list these out, we have a equals 1, b is negative 1, c is negative 6. So negative b all over 2 times a. So minus minus 1 turns into plus 1 up top. 2 times 1 is just 2. So the x-coordinate of our vertex is 1/2. We'll do this in a different color here. Christmas theme today. And then we can plug back into x squared minus x minus 6 to find out what y is. So again, we find the x-coordinate of the vertex. We take that x-coordinate right here, and we plug it into the equation to solve for it. So we have 1/4 minus 1/2 minus 6. And again, feel free just to punch that into your calculator. We're just looking for a value that we can graph here. And this is going to turn into -6 1/4, or -6.25. So our vertex comes at an x value of 1/2, a y value of -625.25. So let's graph these here. So again, we said our y-intercept was down 6, 1, 2, 3, 4, 5, 6 down. Said our x-intercepts were at +3 and -2. And we said our vertex was over just 1/2 and then down a little bit more than 6, so somewhere like right about there. And based off of this, we just put our dots together, and boom, there's our graph. So again, that's the x-intercept, and our y-intercept. So really put together as a collection of intercepts, and our vertex lets us know our min or our max. In this case, it's our minimum value. That's our vertex. So we have all these calculated. If you were to pull this up on Desmos, you'd be seeing exactly the same thing. All right, a second example that we need to be prepared for is when it's in vertex form. So instead of the ax squared plus bx plus c form, vertex form. So remember, your vertex is h comma k, and it's going to make solving for intercepts a little bit more challenging. So again, remember, y-intercept comes when x equals 0. Well, this equation is minus x minus 2 squared plus 9. So we have to plug in minus 0 minus 2 squared plus 9 to find what our y value is here. So that'll be minus on the outside, 4 on the inside, because -2 squared is 4, plus 9, or just 5. So our vertex equals 0, 5. Next, the x-intercepts. This is a little bit more challenging here. So it's minus x minus 2 squared plus 9. Well, we have to do PEMDAS here, so x minus 2 squared. Again, don't want to rush here because we would be wasting a whole lot of time if we got this wrong. So we have a final answer here of x squared minus 4x plus 4. So we can go and plug this back in. So minus x squared minus 4x plus 4 plus 9. Distribute the negative in. Minus x squared plus 4x minus 4 plus 9, or minus x squared plus 4x plus 5. And then finding our x-intercepts, we can set this equal to 0. So now it's your job to keep going, and you can either use a quadratic formula or a box. Just be careful that a is -1 to go through. And again, identify the vertex, and then you can go through and solve. I just wanted to really emphasize two things that are different about vertex form. One is that you will actually have to plug in the x equals 0, and it will take you a little bit longer again. It's not 9. 9 is not the y-intercept. We have to go through and actually calculate here to solve. And the second thing, for finding the x-intercepts, you have to get it into, again, a factorable or a quadratic formula type form, something like this, before you can go through and start solving. Finally, the vertex, that's something that makes life a little bit easier. It's just h comma k, or in this case, if we look at this equation, it would be 2 comma 9. So that one, that's the quick part of it being in vertex form. So really the last thing that we are looking for here is making sure that we have those x-intercepts solved for. And I just realized it's in vertex form. I might have written the wrong thing here. This is the y-intercept. So again, the first thing we solve for is the y-intercept. So apologies for that error there. Realize I just made that mistake writing that down. But again, first one we solve for is y-intercept. Next, move on to the x-intercepts, and then we finish up with that h comma k vertex there. Once we have all of those things, we translate them down to a graph and make our parabolic shape. So thanks for watching, everybody. And again, make sure we're carefully going through calculating these things one at a time. As always, if you have any questions, please feel free to book an appointment, send an email, send a message, any of those things. We are here to help, and we'll see you in that team session very soon.